Good afternoon, everybody. I'm delighted to welcome you all to the second day of the inaugural International John McCarthy AI Summer School here, and delighted to be talking about a topic, AI in sustainable societies. It's crucial to our future, and I know from myself as director of the ADAPT Centre, but delighted to be running this event with RDI Hub and Microsoft, because we recognise that the next 5 years we really do have to be shaping the future for our societies, and one of the biggest impacts that's going to happen with that is the next generation technologies, and in particular in the AI space. It's going to affect how we work, how we learn, how we relax at home or outside, and how we come together as communities. So with all that, I'd like just to introduce the topic through one or two slides, which I'm just going to call up now. So I'm from the ADAPT Centre, and in particular what we've been looking at is how the impact and how we can shape the future with artificial intelligence. And in particular, as we look towards the future, we see it really in terms of technology as three different levels. If we think in terms of technology at the base case, this is around the technology and how it actually forms the technology itself. In AI, in ADAPT, we're really focusing in on AI and the future of digital media technology. That is how we text, how we share images, video, VR, AR, speech, all forms of media. And in the future, we see the world as this blended fusion of the physical world and the digital reality. We see that today, but more and more in the future, we'll see that seamless integration of digital in our lives. And as we look forward to that, and as we look towards what transformations that's going to make, we can think in terms of the actual algorithms themselves, the AI algorithms around understanding language, understanding text, image, transforming it. And we're going to see that media is going to be so much more fluid, in the sense that it doesn't matter what type of media or what type of content you have, it will flow between video, text, image, speech, or whatever. So things in terms of the way we interact will totally change. But we have to think of that as we talk about that in a societal perspective. And in order to do that, we need to think about the individual and how that empowers the individual for a sustainable society. How can we actually interact? How can the user feel in control rather than being part of an automation? How can the user actually have agency and have the technology do what it wants rather than being dictated to? And the third level of that then is, as you begin to do that, you form communities and you have interactions with those communities. That's how you form society. So what does this impact, and how does this impact society, and how does this actually drive forward societies of the future? Societies where we have privacy, where we have proper data governance, where we have the relevant sustainabilities put in place. The ADAPT Centre is looking at these problems. It's across 8 universities, it has 77 professors and over 300 researchers from all over Ireland. Over the last 5 years, it's been funded to approximately 100 million, and we now are looking towards the next 6 years. We have a very ambitious programme, and I'm delighted that a number of our principal investigators have been able to share those ideas with you. I believe yesterday you heard from the ADAPT principal investigator, John Kelleher, about the environmental impact of our AI research, exploring the trade-offs between accuracy and efficiency, and challenging us to reconsider how to measure the success of AI research. And we've heard from our colleague from CIT, Dr. Haytham, who is discussing AI and how it meets the digital health, social science, and agri-tech, and exploring current and unseen environments in the future. And later today, we're going to hear from another ADAPT PI, Professor Roseanne Dial, who'll share insights on digital twins for sustainability. We then will showcase some real-world AI applications using Street View, satellite, social media to help improve our cities and spaces of the future. I'm also looking forward to hearing from a very good colleague of mine, Professor Vinny Cahill, who is a former Dean of Research in Trinity. And Vinny will talk about AI for sustainable cities and smart cities. And finally, later today, we'll also hear from Gemma Clavel, founder of Ethicas, and looking at the talking about 2020 projects around trustworthiness. Finally, I'd like to close the introduction by thanking the RDI Hub for hosting this important summer school that I hope you're deriving a lot of benefit from, and I know we're really enjoying the connection with you. And to Microsoft and the wider team for putting together this program. And we at ADAPT are looking forward to the next year's events already. Thank you.
Thank you very much, Professor Vinny Wade, for that fantastic introduction and great synopsis of yesterday. Hello, everybody. I am Radine O'Connor. I am the Community and Members Manager here in RDI Hub in County Kerry, and I'm your host for today. For those who weren't with us yesterday, we're delighted to have you all here today. As we always want to hear from you, what I'll suggest is if you have comments or questions, just use the chat function, the Q&A function down at the bottom of the screen on the bar, and send any questions or comments my way. If you come in as an anonymous attendee, remember to put your name in the question so I know who they're coming from and who you want to direct that question to. Our hashtag today is hashtag AISS, so feel free to tweet. We want to hear from you. And this session is being recorded. You're in for a treat today because, as Professor Vinny Wade said, we have a great lineup for you. Professor of Computer Science at Trinity College, Dublin, Professor Vinny Cahill, is here to talk to you this morning around road vehicles automations for improved transportation reliability. And before we kick off, if anyone wasn't here yesterday, we love to kind of get a sense of where your mind is at as an audience and as a group around these topics. And we use Menti to do that. So Vinny has sent me a question that he'd like to pose to you. And the question is this: what two factors most influence your choice of transportation mode? And what you need to do to answer this question is take out your phone, go to menti.com and use the code 6797678 and pop in your answers. You will be given two options for answers, or two spaces for answers. I'm going to do this as well as we speak and give you a minute to complete it. So the question is, what two factors most influence your choice of transportation mode? Okay, yes, okay, great. Starting to come in. Okay, so the word clouds are great because they give you a sense of who else is in the room and what are they thinking about. But one of the things that's coming up really strong here is ease, reliability, comfort, convenience, cost. That's an interesting one, Vinny. Speed. Yeah, speed, of course, would come in. Reliability, convenience being a key one. Comfort, still like our creature comforts. Reliability, reliability, frequency, speed, safety, security. Great, keep them coming in. And cost, distance. Yeah, distance, of course, would be, and carbon footprint. Thumbs up for whoever put in carbon footprint. Well done. Health, green, great. Pollution, okay. Being able to multitask during your commute or to wherever you're going. Weather, obviously. Health, travel time. Great. They're still coming in. Super. Frequency. And I'm presuming, Vinny, these are the types of things you expected to see. Great stuff, guys. This is great. Convenience, speed, safety, ease, health. Crowdedness. Now, I wonder 5 months ago if we'd asked this question, would that have been an issue? That's really interesting. Great. I'm just going to give you 10 more seconds to answer because I'm conscious of time, and we'll move into the session then. Travel time, multitasking, yep, great. Okay, and we're going to close that out. And I will share this with you afterwards as well. Okay, so without further ado, remember everybody, if you have questions for Vinny, put them in the Q&As and comments, etc. We're delighted to have Professor Vinny Cahill here today to talk to you about all things road vehicle automation for improved transportation reliability. Vinny, I will hand it over to you.
Thanks, Radine. I'm absolutely delighted to be part of the inaugural John McCarthy AI Summer School. I'm only sad that I'm not actually in Killorglin today. For those of you who excuse me, yeah, for those of you who don't know Killorglin, it's a wonderful place. The surrounding area, the towns of Croman and Glenbeigh are absolutely fabulous, and I absolutely recommend anybody to take the opportunity to go there and perhaps visit RDI as well while you're there. In any case, so my goal for today is really to sort of motivate a research agenda around the use of artificial intelligence and related technologies to improve particularly road transportation reliability. On one hand, it's a sort of a retrospective of some work that we've already done, but as I say, leading into our sort of future research agenda and what we hope to work on in the future. So I'll begin by talking a little bit about what I mean by transportation reliability. I'll follow that up with a brief discussion of the emergence of autonomous vehicles as a sort of key enabling technology, I suppose, for the future. Talk about the potential impact of connected and autonomous vehicles on traffic flow, and look at some of the things we've done in the past that provide some hints as to what that impact might be. And then, as I say, map out our sort of future research agenda. I suspect that not too many people need to be persuaded that traffic congestion is a serious problem. It has a significant cost associated with it, and it has significant negative impacts on environment, on health and quality of life. So I think that's kind of well known. Many initiatives aimed at reducing congestion, broadly understood, public policy initiatives and other initiatives. Broadly speaking, those sorts of initiatives are focused on reducing average journey times. So that the TomTom survey is quite well-known annual survey of international traffic congestion. In 2019, they reported that congestion is at 29% globally. So that means that on average, journeys are taking 29% longer than they would in an uncongested system under free flow conditions where there's no interference between vehicles. And so the focus has been on reducing those average journey times, by, for example, demand management, or typically by increasing the capacity of the network, building new roads, in other words. Demand management is often focused on trying to affect people's choice of modes, moving people away from private cars in particular, towards active transportation options, walking and cycling, as well as obviously to public transportation. What's interesting is that the ECA, which is the European Court of Auditors, who essentially their tagline, I think, is that they're the guardians of the EU's finances. So they have oversight of EU spending. They did a recent report on the impact of about 16.3 billion of European structural fund money that was made available specifically for sustainable urban mobility between 2014 and 2020. And they found, and I was kind of shocked by this, but they found that there is no clear trend towards more sustainable modes of transport in the EU, and there has been no significant reduction in private car usage. This is by way of saying that, you know, congestion isn't going away. Demand is increasing, and we're not seeing significant mode shifts. When we talk about reliability, we're sort of focused more not on the average journey times, but on the predictability of journey times. I suppose with the goal of making journey times more predictable, reducing the jitter, if you like, in journey times. And that might result in on average longer journeys, but it gives users, travelers, operators, logistics supply companies more certainty, right, about travel. There's a significant cost associated with unreliability. Typically that arises from the sort of buffer time that people have to include in their schedules in order to ensure that they arrive on time, whether that's, you know, taking an earlier bus or, you know, starting a journey earlier in order to ensure that you arrive in time for whatever event that might be. So my perspective, and I guess a lot of people's perspectives, is that being able to offer predictable journey times is important to the uptake of more sustainable transportation, right? In particular, public transportation services, but also, you know, emerging trends for shared and on-demand mobility services, you know, really demand predictability if they're going to be used widely. And of course, this also applies to on-time delivery of goods. And again, there's an increasing trend for road transportation delivery of goods. It's interesting that in the word cloud, the word that came up in the center of the word cloud was the word convenience. And actually in many surveys, convenience and usually also speed come up as the key factors that drive people's choices of transportation mode. And reliability, I think, is a big part of that. Okay, so what can we do about it? Well, of course, everybody's aware that there's an emerging trend towards autonomous vehicles. The sort of graphic here from the Economist sort of, I suppose, summarizes, in some sense, you know, our common perception of an autonomous vehicle. You'll see in the graphic there's a lot of emphasis on the sensing component, right? A lot of the conversation is about how autonomous vehicles can sense and perceive their surrounding environment as a basis for, you know, path planning, routing, obstacle avoidance. And so a lot of emphasis on things like computer vision and sensor fusion technologies. And of course that's necessary. But I think what's most interesting, right, is that of course autonomous vehicles are controlled by computers. Right? And so in that sense, my perspective is that actually autonomous vehicles are probably a lot less autonomous than conventional vehicles. Conventional vehicles are controlled by people, so you know they're at the whim of a human who can make, you know, random, arbitrary driving decisions at any given point in time. Because autonomous vehicles are controlled by computers, we have as a society an opportunity to say to a much greater degree how they should behave. Right? So you know, so I think autonomous is actually a misnomer here. I prefer to use the phrase self-driving. Right? And so there's a big question about how we want these vehicles to behave in traffic and what the impact of that will be. And I guess that's motivating our research agenda to a certain extent. Autonomy isn't all or nothing. There's a spectrum of possible levels of autonomy, you know, from essentially providing support for drivers to full autonomous driving. Typically there's sort of these 6 levels are recognized. But you know, as we move towards more and more autonomy, there's a couple of things we can say. First of all, it's probably going to happen. Right? So we will see incremental deployment of autonomous vehicles in different scenarios, different levels of autonomy, but over a relatively long time frame. The average lifetime of a car, depending on who you believe, is something from 8 to 17 years. And so it won't be the next generation of vehicles. It will be incremental. Has the potential to be genuinely disruptive, has the potential to offer lots of beneficial attributes. Safety is obviously a key focus, but access, convenience, and comfort, to a wide range of people who can't currently use vehicles. Individual vehicle efficiency is potentially going to be improved by essentially better driving styles and platooning and other side effects. But the interesting question for us is what impact will it have on the efficiency of the road network and the reliability of the road network? Right? Can we exploit this technology to substantially improve in particular from our point of view, reliability, right, of road transportation? So our work in what I call the free flow project is really investigating what we can do to improve transportation reliability and travel time predictability. From lots of different perspectives. So proactively in terms of thinking about how we can shape demand, how we can introduce mechanisms to avoid congestion due to perturbations in traffic flow, due to junctions, due to other events that might interfere with the flow of traffic, and then reactively when things do happen, how can we react to them in the most efficient way possible to disperse, if you like, the congestion that has arisen. We're looking at a whole range of different settings, from traditional or conventional settings, where we're looking essentially at advanced urban traffic control systems for conventional vehicles, through to the impact of adding autonomous, or I should say probably self-driving vehicles to the mix of traffic, to what happens we have a fully automated system. Right? And looking at both from the point of view of individual vehicles, but also I think more interestingly looking at how vehicles will interact with road traffic management infrastructure, right, to optimize the system. So when I think about reliability, offering predictability in journey times, to a certain extent that's really about sort of keeping traffic moving, right? To the greatest extent possible. What might that look like? I'm going to show you a little concept video. It is a concept video. It's not intended to be an ad for any particular insurance company, but it's one that I like. So you'll see it maps out a somewhat utopian vision of what might be possible, entirely removing traffic lights, for example, from intersections and allowing cars to flow freely across the intersection, avoiding each other in real time. That works quite well when you've got a very large junction, obviously not quite so straightforward when junctions are a bit more constrained. Dublin City Council would tell you that Dublin's road layout is medieval, and so the opportunities are not as great. Nevertheless, it's kind of a motivating scenario, and something we began to look at quite a while ago now is what are the possibilities for cooperative intersection crossing in the presence of 100% so fully automated vehicles. Not going to go into huge detail here, but the essential idea, being a computer scientist, is that we treat this as a resource reservation protocol. In this case, the key resource is road space, and we reserve blocks of road space for periods of time to allow cars to progress without interfering with each other. So each trajectory maps to, if you like, a set of slots that a vehicle can reserve for its journey through the junction. The graph shows that there is potentially some advantage to that. In this scenario here, best case under dense traffic, about twice as many vehicles were able to pass through the junction without stopping as was the case with a conventional traffic light. In this case, it was a fixed time traffic light. So there seem to be some possibilities, to achieve, some sort of improvement, at least in this sort of limited scenario. In the past, we've also looked at what happens in highway driving scenarios, again using essentially a slot-based driving model, where modeled on a sort of time division multiple access methodology, where cars are allocated slots that move along a road, they stay in their slot, and that allows us to regulate the speed and also other maneuvers of the vehicle as they travel along a highway. And in particular, the little graphic at the top right of the screen shows a scenario where we examined what happens when one lane is closed and we need vehicles to merge into the remaining open lanes. Under human driving, and you probably all experienced this, that typically leads to some significant delay and some buildup of traffic as people try to merge. In the slot-based scenario, we're able to show substantial improvements in capacity around bottlenecks by essentially coordinating the speed at which vehicles move in order to, first of all, maintain speed in the lanes that are not blocked to the largest extent possible, but also create opportunities for vehicles in the blocked lane to merge efficiently into the open lanes. Again, this is a scenario assuming 100% penetration of autonomous vehicles. What's more interesting, I suppose, is to look at what happens when we start to put autonomous vehicles into the mix with conventional vehicles, so the so-called mixed traffic environment. And so we've looked at scenarios where we look at the impact on car following behavior of having autonomous vehicles. Again, I should probably say self-driving to be consistent with myself, vehicles in the mix. The diagram shows a profile of a set of vehicles traveling along a highway. Each diagonal essentially represents, and I'm not sure if you can see my mouse. So each diagonal essentially represents a single car, so moving over time and obviously progressing along the road. Color coding shows the speed of the car, so darker is worse. And essentially what you can see here, approximately at this point here, we had some sort of perturbation in the traffic flow. So a vehicle slowed down for some reason, maybe it's random braking. And what you see is that has an impact on all of the following vehicles. It causes those vehicles to slow down, and that impact actually is magnified over time. Right? It affects more and more vehicles, and so you get the emergence of what's sometimes called a phantom traffic jam, just because of that simple perturbation in the traffic flow. In the sort of conventional scenario, 0% self-driving vehicles. What we've been able to show is that, with a suitable car following model, even a small proportion, right, of autonomous vehicles in the traffic mix can have a significant beneficial impact, right? In terms, obviously not of avoiding the perturbation if a driver puts their foot on the brake, the car slows down, but in dissipating, right, the impact of that perturbation. Right? Okay, and so you can see in similar scenarios with higher degrees of penetration of self-driving vehicles, we begin to see a smoother behavior. So we've looked at some other scenarios, again, where we have a mix of autonomous and conventional vehicles, again, with a view to seeing what the impact of lower penetration rates of autonomous vehicles might be. This scenario I'm going to run here compares the impact of a lane closure. So one lane closing, in the case where we have 100% conventional vehicles, versus the case where we have 20% of self-driving vehicles in the mix. Cars are color coded here, so green is moving at a higher speed than red, which is tending towards stopping. And what you'll see, and it's not hugely pronounced in this scenario because the traffic volume is relatively low, but what you will see is that in the conventional vehicle scenario, more vehicles are affected, more vehicles have to slow down, more vehicles have to stop in order to find a way to merge into the traffic. With a higher penetration rate of self-driving vehicles behaving appropriately, right, we're able to maintain the flow to a much greater extent in the open lanes and facilitate cars moving out of the closed lane into the open lanes. Okay, so I guess those scenarios are limited experiments. Most of them are done under a variety of different conditions, but principally in simulators. So, but what they do, I suppose, is, from my point of view at least, they suggest that the presence of even a relatively small proportion of, keyword here, well-behaved self-driving vehicles seems to offer advantages for reliability. The presence of self-driving vehicles offers the possibility of maintaining the flow of traffic over time, not quite at the fully autonomous intersection yet, but nevertheless offers some advantages. It also seems to be the case that higher penetration rates seem to offer increasing advantages. And so that's for me a sort of a important observation, but really what it motivates is the big question in my mind, which is that we need to think about what it means for a self-driving vehicle to be well behaved in this sort of scenario, right? What sort of behaviors do we want? Right? There's a temptation to think of individual self-driving vehicles as replacements for individual conventional vehicles, that will behave in more or less the same ways, have their own self-interest, if you like, as conventional vehicles do. Whereas there really seems to be an opportunity for us to think about how cars, or how other types of vehicles, will play a role, right, in the overall sort of management of the traffic system, and what are the desired behaviors that we want in order to optimize the transportation system, the road transportation system in particular. And so I guess that's our motivating question. So from a scientific point of view, I guess what we're looking at is to a certain extent, what are the limits of this sort of behavior? So, can we design algorithms for optimization of urban and highway traffic that will operate, as a function of the increasing levels of sensor data that are likely to be available by virtue of high numbers of self-driving vehicles, but other IoT technologies available, and the increasing levels of control over individual vehicles that we might be able to exercise as the levels of automation moved from level 0 towards level 5. Our particular focus is on decentralized algorithms that assume the presence of an infrastructure of traffic controllers, but allow those traffic controllers to apply a level of control to the flow of traffic that will hopefully converge on some sort of system-wide optimal solution. So underpinning this work is a body of work on reinforcement learning in particular. We've done quite a lot of work on that, but also on techniques which might be broadly characterized as swarm intelligence, techniques which allow collections of traffic controllers to hopefully converge towards system-wide optimal solutions, within the context of some system, be that a stretch of highway or a set of junctions. That's pretty much it for today. So thank you very much. Obviously, very happy to take your questions now or in the future on any of these topics. Thank you very much.
Vinny, there was definitely loads of food for thought there, and the questions have been coming in as you were going through. So I'm going to go straight to the questions so people have the most amount of time to kind of pick your brain. So just looking at the questions here. So one of the questions that came in was from Anonymous. So what if the number of vehicles required on the road at a time is more than the road's capacity? Kind of what you touched on there. Our Dublin roads might not be what we need them to be. So in such situations, this might arise in like high population dense areas.
Yeah. So I mean, I think a key element of all of this is demand management. I mean, obviously, road space is a constrained resource, right? And so in the first case, I mean, we're trying to optimize the use of that resource, right? And broadly speaking, to move as many vehicles as possible over the road network over time, as is possible. But that's a sort of maybe a naive interpretation, because really what we're interested in doing is moving people and goods, right? And so, there are questions about, if you like, the mix of passenger vehicles, the type of passenger vehicles, the mix of goods vehicles that we can accommodate. And so I think what will emerge over time is that we will see new business models, new road pricing models, enabled by this kind of technology, which allows us a much greater degree of control over the shape of the traffic demand. You can imagine models where, let's say pre-booking of journeys, might be a possibility, where different types of vehicles might be assigned to different lanes or to different parts of the day. So I think that the emergence of particularly sensor technologies combined with that level of control will allow us to shape demand in a variety of different ways that so far we haven't been doing.
Thanks, Vinny. That makes perfect sense. Will came in with another question. I might get you to stop sharing your screen.
Sure.
Cool. So Will came in with another question, and the question is: any surveys results as to how many people in self-driving? Any survey results as to how people in self-driving cars react in a traffic jam? That's interesting.
I'm sure there are, but I don't know them.
It would be a big ask. Great. Okay. So
I mean, obviously there hasn't been very wide-scale deployment of autonomous vehicles to date. I'm not sure that that's a question that we will know the answer to for quite a while. But it's an interesting one, but I'm afraid I don't have any data on it.
I have another question, and this is definitely an opinion more than anything else. And this is coming in from Anonymous, and the question is: Can you please share your thoughts about flying cars for better traffic management and how AI can enable it? That's my favorite question so far.
Yeah, I'm always asked this question, actually, surprisingly. So drones are on people's minds, I guess. And my standard answer is this. My standard answer is, do you cycle? Right? And do you find it harder to cycle uphill? Right? And the answer is usually yes. And the reason for that is that it takes more energy to go up. Right? So I'm not entirely convinced that things that fly are energy efficient. Right? So it might be a benefit. For example, for congestion, it might be a benefit for reliability, but I'd be dubious about whether it's beneficial from a sustainability point of view. And I think there's a whole variety of societal quality of life and nuisance type issues that need to be considered. So I'm not persuaded that it's the way forward, I guess. Again, just an opinion.
Great, yeah. I can't see it myself, but sure, look, who knows? Vinny, another question in here. What are your thoughts on the ethical issues around self-driving vehicles, and when does the car take over from a driver due to fatigue, like to avoid a crash?
Yeah, I mean, obviously tricky question. I think that so as I mentioned, there's a a number of different levels of automation, right, that have been, I suppose, hypothesized, right? And generally a sense that different levels of automation will be used in different scenarios, and in that scenario, right, drivers have to be available to take over, right, in the appropriate circumstances, and that's a big ask, actually, right? So whether it's really feasible to have a situation where a driver needs to be able to take over, right? And we can have an expectation that will happen in some sense seamlessly, right? I think that's quite a big ask, actually. So the sort of the more expectation, I suppose, is that in those scenarios, cars, self-driving cars, will adopt some sort of fail-safe behavior, right? Which often means stopping, actually, right? Or I've seen proposals for runoff lanes and things like that would allow autonomous vehicles to absent themselves from the traffic flow. But I think that's a likely scenario. And some of the technologies that underpin cooperation, particularly between vehicles, are again susceptible to interference, interrupting communications, and so on. So at least in the foreseeable future, I think some sort of fail-safe behaviors will be built in. Okay.
Yeah, makes sense. And like you said, it's a thorny issue. Mayak, it has come in with a question, and it's a good question actually, and it's probably more here and the now than the flying cars, but still. So how, in your opinion, Nick, how do you, in practical terms, optimize automated vehicles when there are human-driven vehicles on the same road?
Yeah. So I think that's the sort of key observation that we've had, which is that, and it's an observation that people have seen previously with systems like cruise control, cooperative cruise control systems, that there is a benefit to the overall traffic flow by having well behaved vehicles in the flow, right? So there are various human behaviors that lead to suboptimal driving, right? I suppose in some sense driving is a little bit competitive, perhaps. Drivers are focused on their own journey time rather than the overall system, and so by mandating probably, right, certain behaviors in self-driving vehicles, they can offer a benefit to the overall flow of traffic, right? That they can perhaps cooperate in making spaces for merging, when lanes are closed, those sorts of behaviours. Right? So there does seem to be a benefit to even small proportions of self-driving vehicles in traffic.
Okay, so there's a case to bring in just a few to make us all better.
Basically.
Man, I hope that answers your question.
There's another perspective on this, which is a completely different perspective, but something we've looked at a little bit, which is could you persuade drivers to opt into adopting some of those sorts of behaviours in a more fine-grained way. So by providing perhaps advanced driver information systems or something like that, which would provide more detailed advice to drivers about what they should be doing in a given circumstance in a way that would allow them to be a bit more cooperative, put it that way. And so that's a sort of an interesting perspective that this sort of research throws up. We talk about persuasive driving, but it's a different dimension.
And the adoption of that will be really interesting with time. We have a question in from Marie. So what companies, Vinny, are testing self-driving vehicles in Ireland?
I don't know the answer to that either.
That's okay.
Right? I mean, there are obviously a couple of companies active here. What their current research programs are, I don't know.
Actually, Marie as well has come back with, do you know if and how governments, local and nationally, are preparing for self-driving vehicles, if at all, Vinny?
Yeah, I mean, I think they are. I mean, I think that there's a lot of consideration of what's happening. I suppose the sort of first phase has really been around enabling testing of self-driving vehicles. So a lot of jurisdictions have now put in place provisions to allow self-driving vehicles on public roads and to operate independently, obviously, of human control. A lot of conversations are happening about the safety-related issues, I would say, in particular, issues related to insurance, desirable behavior around safety behavior. I guess our perspective is there also needs to be a conversation about, what we want in terms of, performance-related behavior as well.
Okay. Yeah, that makes sense. We have a question in from Erwin, and Erwin, this is a quite a lengthy question, so Vinny, stay with me. So it's been shown that building more roads leads to more vehicles on the road, causing congestions, leading to building even more roads, etc. So wouldn't AI optimized road traffic lead to the same problem? And if yes, is this really a sustainable direction?
Yeah, so it's an interesting question. There is definitely some evidence that building more roads creates more congestion. I think congestion is a very multifaceted problem. I mean, there's a lot of causes of congestion. Demand and increasing demand is certainly one of them, and that's partly driven by population dynamics as well. Yes. But I guess that the perspective is that on one hand, there's a limit to the number of roads you can build. Right? I mean, that's probably not a viable solution in the long term. I mean, probably has been the solution of choice in some sense historically. We'll add a lane to the motorway, or we'll build the ring road, or whatever it is. I mean, we're still doing that. So on one hand, we need to make the most efficient possible use of the infrastructure that's there, but the real issue is the demand management issue, right? Of minimizing, the number of private vehicles. So there is evidence that there's a move, at least in certain countries, away from car ownership. More interest, for example, in models like ride sharing and car sharing. Right? In a lot of jurisdictions, that has a negative impact on congestion, because you get an effect where you have cars cruising, looking for passengers. But so fundamentally, I think there is a demand management issue, and again, it's multifaceted. there's a certain amount you can do using technology, as we talked about a little bit earlier in response to one of the other questions. But also it has, a lot to do with land use policy, juxtaposition between where people live and where people work, and how we organize our society. So big questions, but that need a long-term perspective.
Yeah, big questions to tackle. So I'm going to give you one more question before we finish up, Vinny, and then I'll let you go have the coffee for the day. So the last question coming in is from Benny. How can automation handle GPS errors, e.g. when a car is driving on a highway, but the GPS reads its location as driving on a feeder road?
Yep, I think there's a bunch of different issues there. I mean, again, so I think what we're going to see is that the basic technology is getting increasingly reliable, right? But actually, I think what we're going to see is a lot more cooperative location type solutions, right? So relying not only on GPS, but relying on what am I trying to say? Yeah, collaboration between vehicles, as well as between vehicles and the roadside infrastructure. Right? And I think the infrastructure assistance actually is quite crucial in that perspective.
Vinny, thank you very much for your time. We have taken enough of your time at the moment, but it's been really, really insightful. We haven't got to everybody's questions, but I'm conscious that we're going to take 5 minutes before our next session. So, Professor Vinny Cahill, I just like to say thank you very much for joining us on the second day and the final day of the John McCarthy AI Summer School 2020. We might see you again next year.
Hopefully. Thank you.
Thank you very much. Folks, we'll see you all again in 5 minutes. Sorry, at 2 o'clock. And we'll be joined by Roseanne Dio to hear about some very exciting things around twin cities, all to be explained at 2 o'clock.